Let us first understand the learning objectives of this chapter. To use telescope for sky watching, to learn about different forms of light, to explain the contribution of astronomy and modern technology to human progress, to distinguish between the different types of telescopes. In this chapter, we are going to learn about three topics. First is various forms of light, like radio waves, visible light rays, UV rays, X-rays, etc. The second topic we will learn about is different type of telescopes, like radio telescopes, telescopes in space, and two types of optical telescopes called refracting telescope and reflecting telescopes. We will also study about two main types of reflecting telescopes called the Newtonian telescope and the Cassegrain telescope. The third topic we will learn about in this chapter is Indian Space Research Organization (ISRO) and its achievements. Ever since the beginning of time, man has been curious about space and what's beyond it. But how do we understand what is in space if we can't see it through our naked eyes? Nearly 400 years ago, in 1608, Hans Lippershey discovered that seeing through two lenses kept one behind the other seemed to bring objects closer to us. And that's how the telescope was discovered. In the very next year, that is, in 1609, Galileo made a telescope and used it for observing space. He discovered the moons of Jupiter and black spots on the sun. Today, tremendous progress has been made in telescope technology and space research. But will one telescope be sufficient for us to observe space completely? Why do we need different telescopes for the purpose? Are telescopes installed even in space? In this chapter, we're going to study the science behind many such questions. Let's understand different forms of light. So what is light? Light is an electromagnetic wave of energy and light moving around us. Every wave has a characteristic wavelength, the length of the repeating wave shape. Our eyes can see only that light which has wavelengths between 400 nanometer to 800 nanometer. Such light is called visible radiation. Radio waves have long wavelength and is used for transmission of music at radio station. Microwaves have wavelength smaller than radio waves and they help in cooking. Infrared waves have even smaller wavelength and they generate heat. The light that has smaller wavelength than infrared waves is the visible light we see through our eyes. They are all the colors that we see. Ultraviolet rays are responsible for the sunburns on our skin. X-rays are the waves that click pictures of our bones. And gamma rays are energy waves let out by the atomic nuclei, but is also responsible for the superpowers of the Incredible Hulk. Many heavenly bodies emit radiations other than the visible light. Thus, we need different types of telescope to study their sources. Most optical telescopes are made with two or more lenses, as shown in figure 18.1. To collect the maximum amount of light coming from a heavenly object, the objective lens should be made as large as possible. Using the light collected by the objective, a smaller lens, called the eyepiece, produces large image of the source. Light rays change their direction as they enter a lens from the atmosphere and again when they enter the atmosphere after passing through the lens. This is called refraction. Hence, such telescopes are called refracting telescopes. We shall study image formation by lenses in the next standard. The reflecting telescopes are mainly of two types, Newtonian and Cassegrain. As shown in figure 18.2, light rays coming from space are reflected by the concave mirror. Before these reflected rays converge at the focus, reflected again by a small plane mirror. As a result, they get focused at a point lying on the perpendicular to the axis of the telescope cylinder. They pass through the eyepiece and we get a magnified image of the source. The construction of a Cassegrain type of telescope is shown in figure 18.3. The Cassegrain telescope also uses a concave mirror. However, here light rays after reflection from the concave mirror are reflected back towards it by a small convex mirror. They pass through a hole at the center of the concave mirror and then through the eyepiece situated at the back of the mirror. The eyepiece gives us a magnified image of the source. In India, we have several telescopes with concave mirrors. of 2-meter diameter that have been in use for many years. The biggest optical telescope in India, having a mirror of 3.6-meter diameter, is situated in the Aryabhat Research Institute of Experimental Sciences, Nainital. This is the largest optical telescope in Asia. Radio telescope. A large radio telescope called the Giant Meter Wave Radio Telescope, GMRT, has been erected at Narayangaon near Pune. It uses radio waves having wavelengths of about a meter coming from heavenly bodies to study those bodies. This telescope is actually a collection of 30 dishes, each having a diameter of 45 meters. It is called a giant telescope as the arrangement of the 30 dishes over an area which measure up to 25 km across is made in such a way that it works as a single dish having a diameter of 25 km. This means that the GMRT gives the same data that we would have got from a telescope having a single dish of 25 km diameter. GMRT has been made by Indian scientists and engineers at minimum cost. It is a world standard research facility. Scientists study the solar system, solar winds, pulsars, supernova, interstellar hydrogen clouds, etc. With the help of the GMRT. Scientists from all over the world come to India to make use of this facility. In 1990, the National Aeronautics and Space Administration launched into space an optical telescope called the Hubble Telescope. It has a mirror of diameter 94 inches and is orbiting the Earth at a height of 589 km from it. This telescope is still working and has helped to make important discoveries. In 1999, the National Aeronautics and Space Administration launched an X-ray telescope named Chandra in space to study X-rays coming from heavenly objects. Special mirrors which can reflect X-rays were used in this telescope. Chandra has given us very useful information about stars and galaxies. The telescope is named after the famous Indian scientist Subrahmanyan Chandrasekhar. India has developed a sophisticated space technology system. Over the past few decades, that plays a significant role in sectors ranging from agriculture to medicine. Indian Space Research Organisation, ISRO, has had many remarkable milestones since their launch in 1969. Because of the INSAT and GSAT series of satellites, telephone, television, and internet services are available everywhere in our country. The EduSat satellite is used exclusively for education. The IRS satellite series is used for the monitoring and management of natural resources as well as disaster management. AstroSat satellite has ultraviolet and X-ray telescopes and detectors. It is a unique system having different kinds of telescopes on a single satellite. ISRO created a world record by launching 104 satellites in single mission on 5th February 2017. Thanks to ISRO, India became the first country to successfully reach Mars in its first attempt.